come up to Right, my name is Doug Merrett from Salesforce.com, and today's Salesforce1 Platform API Series webinar is all about fast parallel data loading using the bulk API. Without further ado, let's get going with this. And the first slide to show you is our safe harbor slide, because as you know, Salesforce is a publicly traded company, and you should always base your purchase decisions upon currently available technology versus anything I promise which is future oriented. That being said, this presentation is about current technology, so I don't believe this will be a problem. So my name is Doug Merrett. Actually, I'm wearing the same shirt today. It is summer in the UK, which is quite nice. And I'm the principal architect at Salesforce for Northern Europe. I've been here for 6 years, and my role is working in the platform area to help customers understand a bit more about how we do what we do and what the magic is behind the scenes. So then moving on, you can actually look at Developer Force in the latest news. You can follow us on Twitter with force.com handles and the Force webinar as well. On Facebook, we're Developer Force Community. In Google+, Developer Force again Community. In YouTube, we've got a great bunch of videos up there on Developer Force, and LinkedIn, obviously, the Developer Force group. So that's all there for you. There's a whole bunch of great social information up there. So please have a look around, and I'll also be giving you some more links to important documents towards the end of the presentation. You will be getting a copy of these slides, and a recording will be posted in about a week or so's time. And let's have a look at what we're trying to achieve today. So, you know, how fast can you load data into Salesforce? That's one of the questions people ask a lot. And the plan is today to discuss how we're going to do that for you. And you know, in reality, that's quite a broad question. But I think probably more detailed question is, you know, how many records can you load into Salesforce within 1 hour? And that's one of the things which I think a lot of people are needing to do, having a lot of big data being loaded up in your system, either from external integrations or from the initial data take on at the beginning of your project. So let's have a look and see you know, what you're looking to do. Well, if you look at this slide graph, you're looking at, you know, how many records you load in per hour, and obviously you want to be as far to the right as possible. And today we're going to show you how to get up to that side of the graph. So let's have a quick look at what parallel processing really means. And parallel processing is what we're going to be achieving with our bulk data loader. So let's have a quick look at what parallel processing really means. So, come on, machine, go to the next slide. That's better, right. So imagine you're digging a ditch in your backyard, and if you're the only person doing it, it's going to take quite a long time because the ground's quite hard and you've got your shovel and you're digging away happily. And it will take you quite a long period of time. And that's what we're trying to achieve. We actually have a ditch being dug, and in serial processing, you're the only one doing it. And that means it will take you some time, and it's a bit of a challenge. Whereas with parallel processing, what we're doing here is getting a bunch of shovels from the hardware store, a bunch of your friends, and, well, hardworking friends, probably not friends too much longer, and we start digging the ditch together. So we all share the load, and we can get the load done in a much, much quicker time. So having parallel processing actually enables you to get much better throughput in your environment because of that. And the degree of parallelism is the number of shovels all working at the same time. And that's what we're trying to achieve. We're trying to increase the parallelism to get the number of processes or threads to the biggest number possible to make things go through the platform as fast as quickly as possible. So let's have a look at this in graph form. So what we have is, let's say we had 20 million records and you wanted to load them in. If you loaded them in serial form, as you can see at the bottom, it'll take a period of time. But what you would like to do is actually load in 5 million records at a time, but load them in parallel. So we actually have 4 threads there doing the work. Now, that's perfect because if you've got 20 million records, it takes you know, 20 hours, for example. And if you wanted to load in 5 million records in 4 threads and it only takes 4 hours, it actually perfectly fits the process and it's exactly optimal. And that's what you would like to achieve, or as close as that's possible. whereas sometimes you get suboptimal processing. And why is that? Well, the whole point of suboptimal parallel processing is where sometimes things cause challenges, like the degree of parallelism actually isn't as good as you would like. And why does that actually happen? What causes these issues? What makes the parallel not actually as quick as you'd expect? Well, it's to do mainly with these things. So inhibitors, like blocks or exceptions or triggers being fired or relationship challenges, etc., etc. And it's really a case of, we're talking about a ditch, for example. If you've got 15, 20 people trying to dig a ditch that's only 10 meters long, then you're going to be getting in each other's way, and you're going to be causing each other problems. Actually, it slows down, so you can't get perfect parallelism unless you can get rid of all of these inhibitors. So what we're going to do is discuss these inhibitors, which you may have come across yourself when you're doing when you're actually doing your bulk loads. So let's have a look at some case studies and work out how this works. Well, today we're going to get our hands on with the Salesforce bulk API, and we're going to discuss serial versus parallel data loads. We're going to actually discuss what degrees of parallelism and throughput really mean, and actually show you how to measure those, and then how to identify inhibitors for your loading and how to help you achieve maximum throughput. Now, I'm actually not the original author of this webinar. The guys who originally gave this a while ago were part of our customer-centric engineering group, and what these guys do is they discuss this sort of issue with lots of our larger customers having problems loading in their 50, 80, 200 million record tables into Salesforce during initial load, etc., etc. And what these guys do is sit down with the customers, understand their issues, and actually come up with some ideas on why this actually happens. And they've written some fantastic wiki entries, and also have this particular webinar as their output as well. And towards the end of the webinar, I'm going to share with you a link to the wiki to enable you to have a look at that information and share that data with you towards the end. So let's have a look and actually see what this is all about. So let's have a look at some prep work here. What are we talking about, and actually what have we got here? Well, what we have is the Salesforce bulk API. Now, because you're on the call, I'm assuming you know what the bulk API is, but just as a brief recap, it's an asynchronous data loading technology. So what we do here is we load a whole bunch of data into Salesforce as fast as possible, and then Salesforce takes that data you've loaded up, breaks it up into batches, and then processes it as soon as it possibly can. So to do that, it's based upon a REST API, and what it does is the tool that you have that uses the bulk API will just stream the data as fast as possible into Salesforce. We then capture it, keep it there, and then batch it up and then process it through. Many, many tools use the bulk API. For example, Salesforce has our own data loader tool, which we'll discuss a bit later on. But many, many partners of ours, integration partners, have actually got technologies that use our bulk API to give you very efficient loading. And you can also use any programming you'd like. In fact, today I'm going to be using a Java application to show you how this actually works. Now, we're going to be showing some code snippets during the presentation, and that uses the Java language and also the web services connector for Salesforce. It's a great little library to help you build Java applications that can use either the SOAP or REST or bulk API, and it makes life a heck of a lot simpler. So any of you out there who write Java applications or want to speak with the Salesforce API, I can strongly suggest that you look at the web services connector. If you do a search on Google for Salesforce WSC, so that's Salesforce, then a space, then WSC, that's Whiskey Sierra Charlie, the web services connector, and that will give you a pointer towards the actual library, how to make it work. I've used that myself a fair few times now, and I think it's a fantastic tool to make life a lot simpler. So let's have a look and see actually what we're going to be loading up here. This is our schema. We have the standard Salesforce account object, and then we have two custom objects, the order and the catalog. Now, at the moment, we have 500 accounts in the system, and we have 50 catalogs on the system already preloaded. And what we're going to be doing is loading up 1 million records into the orders table. So when you're looking at 1 million records into the orders table, that's only 2,000 orders per account. So it's not that many, but it can still cause a problem with SKU and with data load. And we'll talk a little bit about what SKU is a bit later on. Now, if you notice, the relationships between the account and the order are both lookup, and with the order and the catalog are also lookup. So we're doing lookup relationships here. We're not doing master detail. So just keep that in mind. So then let's go through and see what happens. So what we're going to be doing is discussing a recurring theme, which is the RIP, or the realization of the issues, the investigation of the issues, and the planning of your data loads. So you want to try and get your data loads to rip through, and that's what we're going to be focusing on today as we go through. So the first thing is, let's look at some case studies here. What we're going to do is build these case studies, and we're going to go through in detail and explain each one in order, and then we're going to actually show a couple of them running at the same time. So the first one is the simplest one, and that's the serial data load. Now, as you can expect, what we do with a serial data load is we just load all the records in one by one and using the bulk API, and it's going to be the slowest way to do it, but it's always going to be guaranteed to finish. And this is the example here. We've got only one thread being used. Now, we talk a little bit about threads. Actually, we'll talk about the threads now, I suppose. It makes sense because we're going to be talking about them quite a lot through the rest of the presentation. The way that Salesforce works, we're a multi-tenant architecture. So we have many, many threads out there for processing these batch jobs. So when you're running in your version of Salesforce, you may think that you're the only person using Salesforce environment, because that's what it does for you. It isolates you from everybody else. But in reality, you're sharing your version of Salesforce with around about 10 to 20,000 customers. And they could all be doing batch jobs, they could all be doing bulk API loads, etc., etc. And what we do as part of the service is we have this thing called a processing queue. And we have multiple threads that actually will take that information off the queue and process it as quick as it can. So each of these threads can actually do part of a load. And in this particular case, with the serial load, what we're doing is we're creating 100 batches of 10,000 records each, and we're doing them one after the other. So when the first one finishes, we'll get on to the second one, and then et cetera, et cetera, et cetera. And that will take a period of time. And we're not using any other threads. So actually, even though we could use maybe 20, 30 threads, depending on how many are available to us, and that number will go up and down, what will happen is we have only one thread being used. And if you have any questions about any of this sort of stuff, please ask in the chat window in the webinar itself, and I'll get through to those questions either during the presentation or at the end. Now, let's have a look at a code snippet behind this. This is a little code snippet inside the my application that I'm using at the moment, and it's configuring the job for the asynchronous call. Now, we're setting the object up, we have the operations and insert, the content type's a CSV file, and we're setting the concurrency mode to serial. Actually, we're telling the environment, actually don't use all the threads, just do one at a time, and we'll go through that as we load. Now, very importantly, there are some limits to worry about when you're looking at the bulk API. Now, here's another part of the code snippet as well. And what we're doing here is inserting all the data into the environment. But the challenge is the file has to be read and broken up into batches. Now, the limit on a Salesforce batch is either 10 million bytes or 10,000 rows. So whichever one of those we hit first, we actually have to stop so we don't load in too much data into the environment. So that's the only thing we need to worry about, 10 million bytes per batch and 10,000 rows per batch. So now let's have a quick look at the actual job itself. What actually we do here is we load this job up, and then we tell it to process all these jobs, and we wait for them to finish, and then we check the results. And that's how it works. So let's have a quick look at the demo serial example. So if I flip into my Firefox environment. Oh, went too far. Go back around. There we go. Right. Okay. So this is my Firefox environment. Let's have a quick look at the schema behind here. So if we go into the setup area, we go into our create objects, and you can see the three objects that we spoke about earlier. Sorry, the two custom objects, the catalog and the order. And what I'm going to do now is have a quick look at our jobs that I loaded earlier on. So let's go down to the bottom here, and inside the jobs area, there's a bulk data load jobs link, and we're going to be spending a lot of time in there today. So in that environment, you can see a whole bunch of jobs I've done in the last period of time. And this one here, this one is actually the bulk load which I did, which loaded in my 1 million records in serial time. Let's have a quick look at that. Let's drill in. So if we click on that one and drill into the job, you can see when it started and when it finished, how long it took to run. It took 1 hour and 17 minutes to run. We loaded in the order object using CSV, and it was a serial concurrency mode as we set up in that application itself. It ran, it completed 100 batches as we'd expect. It's 100% complete. It loaded in 1 million records and no records failed with no retries. And the total processing time up here is the amount of milliseconds it took to actually run inside our environment. Now down the bottom here in these batches area, you can actually see each particular batch was being created, and each batch took around about 42 to 65 seconds. So we have a quick look here at a bit more of them. See, most of these finished between 40 and at 40 seconds and a minute for each particular batch. And if you look at one of these result sets, you actually see the CSV result showing you which records were loaded and what the ID of the result was. So that's how you can navigate around your bulk data load and actually get a whole bunch of information behind there. Now the Apex processing time is 0 because there was no database triggers involved in here. This is a totally clean environment, so there's no triggers. That's why you don't see that sort of stuff. So that's the load we did, and the reason I did it beforehand was because it takes about 1 hour and 20 minutes. I didn't want to actually waste your time and mine sitting here watching the clock go around. So I finished that up a bit earlier on. So let's now go back into the presentation and just show you what we're discussing here with the detail. So if we come back into the demo and back into here and have a quick look, what we did was we loaded in 1 million records. None of them failed. It took 77 minutes to actually do the load, and the work completed was actually how much CPU time was taken. This is 75 minutes of work. So we managed to load in roughly 13,000 records per minute, and we had a degree of parallelism. Now, what this is a calculation which determines how good your parallelism actually is. Now, to do the parallelism calculation, you divide the work done, so the 75 minutes worth of work, and how long it actually took to do it in real time, which is 77 minutes. And in this particular case, we get 0.97, so roughly 1. That's the absolute smallest you can get, because you can't get it going slower than one thread, basically. So what we're trying to do here is increase our throughput, because obviously, loading in 1 million records, you want it to go a lot faster than in 1 hour. So let's look at this in graph format. So what we have is the serial run. We've got a degree of parallelism of 1, and what we have is there's a graph, and the line going up to the right, this one here, one going up to the right, is the optimal line. This is what we're going to try and achieve to get on, and try and move up this end as far as possible to actually give us some great values. So let's have a look at doing some parallel loads. Let's come back here and look at doing some parallel loads. So what we're going to do first of all is use up as many threads as possible. Let's have a quick look at how that's going to work. So in here, we have our multiple concurrent threads. So what we're going to be doing now is we're going to have one job made up of 100 batches with 10,000 records per batch for a total of 1 million records, but we're going to enable parallelism. And to do that, all we've got to do is turn one little switch on in our code to say parallel versus serial. Now, when we do that, what we're telling Salesforce is, right, give me as many threads as I can get to actually do this load for me. And each of the batches will be handed out to a thread, and each thread then can process that in parallel, which means we get great throughput in that area. Now, you're going to get competing jobs from other orgs. So sometimes you might get 15 threads, sometimes you might only get 2. It depends upon how many other people are doing things in the environment. But if you can use as many threads as possible, that's great. So here's the code example, and all we did was change that serial we had before into parallel, and that's it. That's all we had to do inside the code to make that work. So let's have a look and see how we do this. Let's have a look at a parallel load. So we go back into our environment. We go back to our monitoring area, which we are here. I just want to make sure we don't have any orders in the system to start with. So if I do a view on all orders, I can see we don't have any at all, which is great. And what I'm now going to do is have a quick look at the objects just to make sure that everything's fine. So if we go to our order, we can see we have our two lookups, one to the catalog and one to the account. And in the account object, we have a link here saying we don't want to allow the deletion of records as part of a lookup relationship. So we're making sure that you can't delete the account object if you've got existing orders. That's part of the schema that we've designed to make the system work appropriately. So now if we go back to our order table, sorry, go back to our job look down at the bottom here, show our jobs. And what I've done is written a little Java app, and I'm going to go to that now and do my parallel load. And that's this one here. It's my parallel load. So what I'm doing is running Java. I'm putting in our particular bulk load in parallel class, telling it to load in the order object from the order data CSV. Now this CSV file is actually it's a random file, so the data is just in a random order, and we're putting the output of this to the parallel load log. We just start that up and let it kick off. It's doing its thing. If we come back into Salesforce, refresh this page with F5, and you should see this job started up, which is great. And it should start doing some work for us in the background. So refresh the page again. Let's head into the job ID and have a look. So we've got no batches currently. It's doing an insert. That should be running. Okay, let's go have a look at my code again. Ah, that's not very handy. The CSV file cannot be loaded. Ah, I know why. My apologies. I actually have got that loaded up into Excel at the moment, so if I can just get rid of that to stop that from happening. That's one of the things you get for doing demos, right? We don't want to actually save that. I think let's run that again, shall we? Let's go back and run my data load. What's wrong there? Data order, data CSV. Order data serial. Ah, idiot boy. Actually, if I could write my stuff out here, it would make my life a lot easier. So that's for serial. My apologies. So let's do the order data serial, and we just kick that off. Okay, no errors this time. That's good. So you can tell it's a real job. We're actually doing this stuff. Now you can see these two actually didn't work, so we just abort those two because actually it didn't start. Just abort those two there that we had. The ones that didn't work. And the one that's currently loading here is the one we need to have a look at. So it's fired off. It's all working nicely. And you can see that we've got in progress 10 batches. We've processed 3,600 records, but we've got some failures here. So what's going on? We're actually doing our load in parallel, but what's actually happening here? Lots of retries, lots of things. Too many lock failures. Okay. That doesn't sound good. We've got lots of failed records here. So we'll just let that finish running, and we'll discuss what's actually happening here at the same time. So while this load's going on, what I'd like to do is go back to the presentation and show you some other things around what we're discussing here. So let's have a quick look and actually understand why this works. So this is lots are causing the problems, right? And the retry logic isn't really cracked up to be. It doesn't really work the way you would like. So it's a bit of a challenge, and it doesn't quite do what you'd like. Now, what's causing those problems? What are these issues that we have? Now, locks are going to hurt our throughput, and that's our main problem here. Because we're locking up records, and other people need to have those records to do the data load, it's actually causing those problems. And the retry logic actually creates more work, and it hurts more than actually it helps, unfortunately, which is a real challenge. And it's just one of those things which drives me mad. Because you'd expect the data load to just happen, and that would be wonderful. Now, with this load, it actually isn't doing what we'd like. So what I'm going to do is go back into my environment, and I'm actually going to abort this load because it's not actually working. so I don't like this. Let's just shut it down totally so it doesn't actually work. And if we go back to our list of jobs, I actually had one before that had the same problems. So this is the one that I loaded up that actually failed. This is the one that actually I want to look at. This is the one I did last night. It actually failed. It took 17 minutes, 45 seconds to actually do the load. It finished doing the work, but 82 of the 100 batches failed. 82 batches failed. And we only processed 585,000 records, and of those, nearly 200,000 failed as well. And there's 944 retries. That's pretty horrendous. And look at the processing time. And that's a long time. Let's have a look at the actual detail now in the PowerPoint. So if we go back to our PowerPoint presentation, let's have a quick look here. So we loaded in 17 minutes time, which is nice. It's come down from an hour or two. But we actually took 3 hours and 15 minutes of computer time as we do that work. That's horrendous. It's not very good whatsoever. And we managed to load 22,000 records per minute, which is roughly what we did in the serial load. So actually, it took a lot shorter time, which is fine. We only processed 20,000 records at a time. Sorry, 20,000 records a minute, which is okay. We had a good parallelization of 11.5, but the trouble is the computer actually was spending 3 hours, 15 minutes inside the Salesforce doing this load, and we only loaded in, not even half of the records. So in reality, this was really bad. It worked significantly harder for no increase in throughput, and what actually happened was the data actually didn't get loaded. So we had a massive failure there. So what caused the problem? Well, it was locks. And how are we going to fix that? Well, either load it in serial, because if you load it in serial, you're not going to get any problems with locks because each batch does it in its own way, or you need to manage those locks. So let's have a look at it in a graph again and see what happened. So this is our parallel one. So we started off in serial over here. Now, we didn't increase our throughput at all. We got great parallelism, which is fine, but it just didn't work at all. So that is just not a good load whatsoever. So let's have a look at how we're going to do this. Let's optimize it. Let's make our data load RIP. Now, how are we going to do this? Well, we need to realize what the problem was. Well, it was actually locks, which caused problems with our parallelism. Let's investigate and see what caused the locks, and let's plan and manage those locks and see how we're going to fix that. So what we're going to do is actually modify the schema. Now, how are we going to get rid of these locks? Well, at the moment, if we go back to our Salesforce instance, let's go back to our bulk data jobs. They're all tidied up, all finished. If we go into our schema and have a look at this again, in the order object, in our catalog reference, what we're doing here is saying, if the lookup record's deleted, we just clear the value of this field. Now, because of that setting, that's the default that Salesforce has, it won't cause any locks when we try and actually create the order record. But if we go back to the order and have a look at the account lookup reference, it says don't allow deletion of the lookup record as part of a lookup relationship. So what we've got to do here is actually mark the account record saying, actually, you're associated with this particular order, so don't allow delete to work. Now, because we're updating the account object, even the background, you can't see this field, but it's being updated. We actually have to lock the record so people can't mess around with it. Now, because we've got this load happening in parallel, what happens is, one batch of 10,000 records is being processed, and a second batch running at the same time will actually try and get locks on the same account, and that causes the problem. So let's have a look at how we're going to fix this. So what we're going to do is we're going to modify this, and we're going to set the clear the field, and that way it's back to where it should be. Hit save, and we've now fixed the schema issue. Now the trouble is, I will talk about this a bit later on. So we fixed the schema issue. Let's go back into my orders, and this is a nice feature we have in the. Whoops, my apologies. Let's go back. In the order object, there's a great feature that we have in there, which is truncate. Now, there's a setting in the user interface setting, which you can do yourself, saying you want to show truncate in the on the custom objects. What truncate does is delete all the records we have, because in my order table, I actually have now got some orders, because some of them actually worked in that load we just had. So what I want to do is get rid of these to make sure that my load will happen properly the second time round. So if I go to my truncate, it's going to say, are you really sure you want to truncate the order record? And I say, yes, I do. And just by hitting that button, no matter how many records are in the table, that table has now been dropped. It's just gone away. So all the data has been deleted in there. So just by doing that, Salesforce will go away, do that truncate, and in a second, what we're going to get is the results page, and I'll be able then to tidy some things up. So now we have this deleted object, which is order truncation. I'm going to erase that to get rid of all the data. And if we now go back to my order object and refresh this, you'll see we've got a grand total of no records. So that's a very handy little way in your development environment. I wouldn't turn this on in production, but in your development environment, it's a great way to get rid of big data tables. So let's now go back into my setup area. I'm going to go down to my bulk load again. Look at my bulk data loads. And now I'm going to go to my other batch task. That's the one that I killed, which is great. Let's load up the other one. Now, this is the my apologies. I shouldn't have done that earlier. That's fine. What I need to do actually now is go back and load this up properly. So what I need to do is load the order data serial. Hang on a second. I'll get the name of that file. The demo gods were not smiling on me this morning. My apologies about that. Let's go look at order data serial. Okay, order data. Right, so what I'm going to do is actually use this and just load in the standard order data. So doing a normal parallel load, just with a normal order data. So let's run that, make sure it starts. And if we go back now to my process job, right, it's loading along, great, okay. Let's have a look at this one and see what's happening behind the scenes here. So now we're doing lots of loads. We refresh the page and it's loading in lots of records. We're flying along quite nicely. We're doing a parallel load on the order object again, and everything's now taking around about 8 seconds to do a batch, maybe 13 seconds. So just keep watching what's going on here. As you can see here, the in progress batches, 15. That's how many people we have currently, how many threads we have running. Now we have another refresh. We've got 18 running for us. And now we've got 18 again, which is great. So loading this data in, and we're up to about 100,000 records already, which is fantastic. We just keep having a quick look at this to see how we get on. Loading the data through, and as you can see here now, there's no retries and no failures. So just turning that particular feature off actually solve that problem, and that's a fantastic thing. So we just refresh this. We'll get in there. It's completed 7 batches already. We're still loading in these 17, which is great. So what I'm going to do is hop back into my presentation, and we'll just see what's going on there behind the scenes. So if we go back to my presentation, so what we've done is had a look at that particular load, and we're making that work by actually modifying the schema. So what I'm going to show you now is the result of that. We'll come back to that in a second. Now, we loaded in that million records. None of them failed. It was great. It took around about 3 minutes and 30 seconds, which is fantastic. We did an hour of work within that 3 minutes and 30 seconds, which means we had a degree of parallelism of 19. So we actually had a fantastic parallelism here, and we loaded roughly 320,000 records per minute. And we did that because we turned our locks off, and that was fantastic. So that made a brilliant throughput. And look at it on the graph. You've actually got your where you want it to be, perfectly on that line. So we're doing, this is the best we're going to get, which is wonderful. So nice parallelism, and we've got great throughput as well. So that's exactly where we need to be. Now, unfortunately, what if we can't change the config? right? What if we, we eliminated the locks by actually changing our config? What if you can't do that? Well, what you can do is actually order your data. If you can sort your data to make life a lot simpler. So if we go back now into our browser, have a quick look here, see what we're up to. Loading along quite nicely, and we've got our, more than halfway through now. It's trundling along quite nicely. We completed 45 of the batches. What I want to do is just finish to wait to show you actually how that gets through. And while that's loading, just chat amongst ourselves. But the key thing here is the ordering of the data will actually help you keep the lock involved while actually doing the load as you'd like. And when I come to actually show you how this works, that should make a lot of sense. So what we have here is the configuration which I changed to get rid of our locks, and now the load is working beautifully. But what we're going to do in a second after this load is finished is actually show you that you can also achieve the same sort of throughput by actually ordering the data before you do the load, actually sorting the data before you do your load. So let's have a quick look at that data while it's finishing our load. And if we flip back into the data, if I load that data up into excuse me, into my Excel spreadsheet while it's doing its work. Million records in Excel on my little laptop takes a little bit of time, so my apologies about that. And it's probably faster loading into Salesforce than actually loading to Excel, which is quite strange. So now we've got it in Excel. What I need to do is just expand this view so you can see it. So what I've done is I've got my account ID and my catalog ID and my two dates. Now, as you can see, this is just a random order, and that's the challenge, right? Because we have batches made of 10,000 records, and we're locking these records up. That's the key problem. So what I'm going to do now is you sort this column. So we go across to the sort environment, sort A to Z. We want to expand a selection? Yes, we do, and we sort it. So what we're doing now is we're actually going to expand all across here and then sort the whole lot down. Now, while that's happening, okay, it's nearly finished doing the sort. And come on, machine, catch up. Nearly finished sorting, redrawing a page, and we should be there in a second. Okay, come on. Okay, so now it's been sorted. So now we've got it all sorted up by the account ID. If we have a look at row 20,000, for example, that just shows you the records that are here at row 20,000. And this is actually one of those breakover areas where we have different batches. So this part here will be in one batch, and that part there will be in the second batch. And we've got the same account, and that may cause a slight clash. But the point of it is they shouldn't clash often because we're sorting it, and that should make life a lot simpler. So I'm going to get rid of this now. Not going to just save the changes. Now let's come back in here and see actually how we've got on with our previous load. So there you go, we finished. Took 5 minutes, 35 seconds, and we had no failed batches, no retries, nothing. Worked perfectly. And that's the example of turning off our locks. So now if we go back to my orders, and if we refresh the page, you'll see that we actually have pulled in our actual data set, which is great. What I'm going to do now is truncate my order table again to make sure that I can do a load again. Truncate the order table. Okay, that's now truncated, which is nice. Get rid of it totally. And go back to my objects. And it's time now to modify my order object to put that restriction back in again when we took off the account. So what we did before was actually we changed the schema, but that's not necessarily a good idea. So what we're going to do is change the schema, and we're going to make it back to what it was. So don't allow the deletion. So we do that, put the locks back in. That's going to cause locking again, which is fine, because now actually we've sorted that data. So let's go and now have a look at how we're going to do the load. So if I go back to my bulk data load here, and what I'm going to do now is run this with the sorted CSV we just had before. And if we run that, to kick that job off, let's go back into my bulk data load area. I can bulk data those jobs. And you see this one now is loading away happily, one we just started then. And that's loading along quite nicely. We've got 10,000 records already processed. And as you can see, there's no locks, no record fails, et cetera, et cetera. And that's just loading up beautifully with that lock set back in there again. But because we've sorted the data, actually it's loading in quite nicely. And we've got a couple of 14 batches in place at the moment, so we're getting pretty good parallelism as well. Salesforce isn't that busy. We've got 16 now, et cetera, as you can tell. So that's great. Let's now go back and look at the PowerPoint again to show you actually where we're up to. So what we've done here is we have looked at the ways and means of changing the way the data works by either eliminating the locks, by changing the lookup permissions, and this time actually we've solved the problem by ordering the data, by actually sorting it, which is great. Now let's have a talk about how this actually works while we're doing the load. So you know, what actually causes locks? Well, master detail causes locks because it obviously has to update information in the parent record. And lookup relationships that have that flag set also cause that same sort of issue. If you've got roll-up summary fields, they can cause locks. Triggers can cause locks because triggers are running on each block of code, and they could be hooking things up as well. Workflow rules again can lock up stuff, and also group membership locks. This is actually for a few special operations. You know, Salesforce needs to take out an organization-wide group membership lock, and this is to avoid exceptions when you're doing when you're adding users to the sharing table, or we're changing users' roles, or you're adding a role to the role hierarchy, or adding territory to territory hierarchies, changing the structure of your hierarchies, taking people into or out of public or private groups, queues, etc., etc. Every time you do that, we actually take a lockout on the group membership lock, and that can cause challenges as well that you're not quite aware of when you're doing your load. So you need to make sure that you either do it serially, or you know, that's just the way it is. You need to do those things in serial, which is a bit of a shame. So while that load is happening, let's go back and have a quick look and see where we're up to. We have now loaded in, we're nearly halfway there. See, again, no locks and no retries, no failed batches. Everything's worked out really nicely here. So now our lock setup is there, but because we've sorted our data, it's coming in appropriately, and it's not actually locking up any records, which is fantastic. So that's working out really nicely. So very happy about that. And you know, we'll see that finish in a couple more minutes. Now, if we get back into the PowerPoint presentation again, let's have a quick look and see where we're up to here. So the parallel load, this is the sample we've done before. I'm not going to wait for it to finish off, but in this time we had no failures. It took 4 minutes to run, which is great. It took an hour of work, and this time we did, you know, 250,000 records per minute, which is pretty impressive. And we've got a parallelism of around about 16.5, which is brilliant. Now that's an average of a couple of ones I've done before. Now, because we got rid of our locks, we managed to get a pretty good run, but there still was some locks happening. You know, we were still locking, so that had to be done, but we didn't actually have any contention for those locks, which caused the issues earlier. So what we have now, if you look at the graph, is parallel 3 is where you'd sort of expect. It's still on a line, the optimal line, which is great, but it's not quite as parallel as this one here, which didn't have any locks whatsoever. So just putting some locks on, just locking the door, but actually using it, still slowed it down a little bit, but it's still a pretty good load. That's exactly what you should have, because inside your inside your application, you needed to have those locks to make sure it's got referential integrity. So that's the way that works. So if you want to ask some questions, please do ask them in the chat window on the in the webinar, and I'll come through towards the end and actually answer some of these questions for you. If we go back and look at our load, to see how we're getting on with that. Where are we up to now? Up to 77% complete, nearly finished, which is great, and it's only taken 4 minutes so far to do that load. Now that's not bad at all, and this is some of the things that people say with Salesforce bulk API, right? Some people complain it doesn't work very quickly and that sort of stuff, but actually, in fact, if you know what you're doing and you set up your environment appropriately, you can get some fantastic load speeds out of it. And it's just something which I think people don't take into account. You need to have a look at what tools you have, understand how it actually is working, actually see how many of these systems actually can get done for you. And if we have a quick look here, each of these is taking around about 35, 45 seconds for the each particular batch, which is pretty good. And 92% complete. Just make sure we get this thing finished off before we go to the next step. 93. Okay, we're nearly there. We'll let it keep going. 7 more in the queue, and we should get the final results in a second. Right, nearly done, and we're finished. So that took 6 minutes in this particular time, 5 minutes 49 seconds, which is great. Still a very good performance. And the total processing time there was actually 4,800 seconds. So that's quite a bit of work. 4,800 seconds is I can't do the math on my head. So 4,800 seconds is, well, there you go, 80 minutes, 1 hour 20. So 1 hour 20 of work was done in only 6 minutes, which is pretty impressive, which is why you get the great parallelism that we talked about earlier on. So that's our sorted data being loaded in with locks, and that worked out really quite nicely. Right, back to the presentation again. So now we've got our locks being worked, and that's great. But there might be some other reasons to do stuff as well. So the other types of loads we have. Now, because we're running out of time, I'm not going to go through these and actually show you them. But what you're doing here is doing controlled feed of parallel data loads. Now, what does this actually mean? Well, what you're doing is throttling. What we were doing before in all the previous examples was we weren't throttling at all. We're telling Salesforce to use as many threads as we want, as it can use, which is great. Now, doing that means that you get the best throughput you possibly can. However, the throttling can be used to actually give you some parallelism examples. So what you could do here is look at things like parallel extraction and loading. So you want to do a load at the same time as you're extracting stuff. You want to make sure they don't actually overlap. You want to also prioritize some asynchronous processing capacity, because you want to make sure that certain jobs get more priority over other ones. Because even though you are sharing the environment with a whole bunch of other people, you still have a maximum number of things it will do. It's not going to give you the whole pool just for you. It's going to give you a maximum number of threads. So being able to minimize how many threads you're using for some jobs gives more threads for other jobs. And it helps you manage these inhibitors for complex jobs like data skews and multiple locks. So let's say you had both lookups in the order table actually causing locks. Well, how are you going to solve that problem? Well, actually, what you need to do is sort the data first by the account, and then second by the catalog. And that way, you're sorting out both of those in the appropriate order, and you maybe break your data up into account lumps so that you are only loading in one particular account, and that way it'll make life a lot easier for the locking inhibitors in that respect. And you may want to then throttle it back to make sure it works that way. So looking at this with a controlled feed, it's still optimal, but you're only getting 6 threads being used. We turned it down to only use 6 threads because that's the way it's going to work, and that's quite handy. So in a nutshell, there's a whole bunch of information behind this presentation on our website. If you go to developer.salesforce.com/architect, it's a great website to have a look at, and in there is this presentation detail all about the Salesforce bulk API, and I'll go to that in a second. And the bit.ly link, as you can see there, is a link off to the code that actually was run. Now, that only includes the actual code that is there, not the actual web services connector library. You can manage how to do that yourselves. So let's have a quick look at the website just to show you our Architect core resources. And if you look at the top of the page here, you get a whole bunch of good stuff, how the Force.com query optimizer works, how to do performant HTML5 apps, etc. There's a live webinar every Friday, and there's a whole bunch of good stuff down there. And if you scroll down, you'll see fundamentals. You've got integration design, logic design, you've got interface design, and down here at the bottom you have your management. And this is our wiki that the actual guys did. So if you read this wiki here, it takes you into all the detail behind this whole presentation. So it's got a great amount of information on here, great examples, and explains all about controlled feeds and why you want to do things in certain ways. So that's that. Let's go back and recap to make sure we can finish off in the appropriate time. And what we talked about here is making your parallel data loads rip by realizing locks that inhibit parallelism and help you work out what's causing them, and then help to manage around those locks. So without any further ado, let's have a look at some of the questions, shall we? Now, please ask any more questions you have in the chat group. That'd be great. And what I have here is a couple of ones come through. I'm doing 10,000 rows per batch. How many batches per hour can we do? Okay. So in my Salesforce instance, by default, you're only allowed to have 5,000 batches in a 24-hour window, because we're just trying to make sure that we don't let people consume too much resource. Well, if you're doing a huge load, tens of millions, hundreds of millions of records, and you want to do it over the weekend, if you talk to your Salesforce tech support guys, what they can do is get the product managers to up that limit temporarily, just to help you do that huge number of batches over that weekend. So, that's something you can really look at to actually get that sort of information. What causes locks is another question. If you look at the wiki I just showed you, that has a lot of information in there about how that all works. Do I always have to use, okay. Basically, the question is, why can't I use standard tools for data loads? Why not use the Salesforce data loader? Well, the data loader is okay. It's a tool that works, but it's fine for 1 million or so records. But if you're doing more than 5 million records or so, it's not really a good idea. It's not really designed for scale. So what actually we would suggest is that you would use either a custom loading tool like I just showed you there with our Java apps, or you could use one of our middleware tools. We have tons of partners out there who have Salesforce API tools that can actually integrate with that very easily and load in data for you. And the last question we have time for is updates. I'm going to be doing inserts. What about updates? Well, updates should be very similar to inserts, actually. We've done a lot of research behind the scenes, and the updates shouldn't be any slower. Well, they'll be slightly slower, but not too much slower. So you should see that those sort of things work quite nicely. And there's one thing I want to mention before we finish up here, is that when you're doing these bulk loads, the data is already there, that's great. But if you're doing searching, there's actually the search indexing. And what we do is we actually offload a whole bunch of text and stuff into another system to actually then do the searching algorithms upon it. So even though you've loaded up your 1 million records, if you start trying to search for it straight away, it's not going to work because it hasn't been indexed yet. So you need to wait a little while actually for the indexes to catch up. So actually you can do your searching for you. And on that note, we've got about a minute to go. Appreciate your time. Thank you very much. And hope you have a great day. And thank you for attending the Salesforce webinar.